Good morning, everyone. Am I audible to you, everyone?
Yes, ma'am.
Okay, thank you. In our subject, Mathematics 2, we already completed the 2 modules, right? That is regarding to the differential equation. First order ordinary differential equation and as well as the higher order differential equation. Now from today, we discuss the module number 2, Laplace transform as well as the inverse Laplace transform. Laplace transform is named in honor of the great French mathematician Pierre Simon de Laplace. Okay, that is the birth of the Laplace mathematician, and that is the death year of the Laplace transform, 1827. Like all transforms, the Laplace transform changes one single into another according to some fixed set of rules or equations, right? The best way to convert differential equation into algebraic equations is the use of Laplace transform. What is the main application? What is the main use of the Laplace transform? Laplace transform helps to us to convert the differential equation into the algebraic equation, and that's why we can simplify easily. In this section, students get a step-by-step explanation for every concept and will find it extremely easy to understand this topic in a detail. Now, how can convert the Laplace transform, the differential equation, into the algebraic equation? That is the main applications of the Laplace transform. Okay, in the differential equation, we already discussed how to solve the differential equation, but that differential equation remains same and we solve in this way. But the Laplace transform helps to us that convert the differential equation into the algebraic equations, right? In the frequency domain, quickly join remaining student, right? Those who are remaining, join it quickly. Laplace transform converts differential equations in the time domain, right? Therefore, here in the Laplace transform, one variable is the t, right? Time domain to algebraic equations in the frequency domain, right? Thus, three important processes. Which three important processes? Transformation from the time to frequency domain, right? We can transform time domain to frequency domain. Second step, manipulate the algebraic equations to form a solution. And the third step, inverse transformations from the frequency to time. And how can we change the given differential equation into the algebraic equation. These are the three steps, three processes. Okay, we have to apply when we convert the differential equation into the algebraic equation using the Laplace transform. Okay. Now the applications of the Laplace transform. This is applicable onto the continuous function, piecewise continuous function, periodic function, step function, and the impulse function. Okay. Continuous function, you know very well, everyone. Piecewise continuous. Piecewise continuous, I am explaining to you using the graph. This is the graph, and function is not continuous directly, but this break into the sum part, right? This dot are the sum part. Function is continuous, but in some small intervals, right? Therefore, this is the first piece, second piece, third piece, like that. Therefore, that is known as a piecewise continuous, right? Periodic function. You already studied in the first semester the Fourier series, and the periodic function definition is f of x plus p is equal to f of x. That means in the function when we are adding the period, right? Therefore, no change into the function, then that is known as the periodic function. Okay. And we know that in the trigonometric function, the sine and cosine are the periodic function. Therefore, in the Laplace transform, we also apply the periodic function. And regarding the trigo function, we discuss over here only two trigo function, sine function and the cosine function. Why? Because sine and cosine function are the continuous functions. That is the periodic function. And impulse function, that is regarding to the switch on and off, right? 1 minute, everyone. Okay. Clear, everyone? The continuous, piecewise continuous, periodic function and impulse function we will study in the Laplace transform also. Yes. Now this is the formula of the Laplace transform. Laplace of f of t is equal to integration 0 to infinite e raised to minus st ft dt. T is the time domain, right? And this is S is the frequency domain, right? And listen everyone, this is most important. When we apply the Laplace transform onto the t variable, then we are getting the answer into the S variable. Here two variables into the Laplace transform, t and S. When we apply the Laplace transform onto the function of the t variable, then this is converting into the S variable, our answer into the only S variable. This is the formula, integration 0 to infinite e raised to minus st f of t dt. Okay. Now this is the sufficient conditions for existence of the Laplace transform. First condition, the given function f of t is piecewise continuous. That means f of t is continuous in every subinterval. One important announcement, Now, if you leave this meeting, then I cannot enter in this meeting. Okay, everyone? That's why don't attend any phone calls, anything, right? If you left from the meetings, now you can't allow in this meeting, right? Because the whole session going on in this meeting, in, out, in, out. F of t is piecewise continuous. That means f of t is continuous in every subinterval, and f of t has a finite limit, right? The function has the finite limits at the end of the each subinterval. Okay. What is the first condition? The function is the piecewise continuous. Now this is the meaning of the I dot E dot means that is f of t is continuous in every subinterval, and f of t has finite limits at the end of the each subinterval. That is the definition of the piecewise continuous. Clear, everyone? Now Laplace transform of some elementary function, right? We prove this formula. You can write it in your notebook also. The first formula, Laplace of k is equal to k by s, where s is a positive, s greater than 0, and k is also greater than 0. Okay, I am waiting for 2 minutes. Everyone note it down this formula quickly, then after I will explain to you. If complete this, then write yes into the chat box, everyone. Yes, Murtuza. Murtuza, complete this slide. Yes, Saurav, but I will ask to you, Murtuza. Murtuza, quickly unmute yourself. Okay, Sridhar. Yes, Murtuza. Okay. Now prove that L of k, L means Laplace transform of the k is equal to k by s. This is the formula. S is the positive and k is also the positive. And remember, student, we apply the Laplace transform onto the positive terms generally. Now, apply the definition formula. This is the definition formula. Laplace of f of t equal to integration 0 to infinity e raised to minus st ft dt. Okay. Now here our f of t is given into the bracket. Here ft equal to k, right? Therefore we put it over here and also here, okay? In this, apply the value of the f of t. Okay, now k is the constant. Therefore, write outside of the integration, and e raised to minus st integration is e raised to minus st divided by minus s. E raised to minus st integration is e raised to minus st divided by minus s, and the limits are 0 to infinity. Okay, now most important thing, everyone, when we apply the infinity, I am writing over here. When we apply the infinite, therefore e raised to minus infinite, therefore we can write 1 by e power infinite, okay? And e value is 2.7183, therefore 1 by infinity. Now what is the value of 1 by infinity? Yes, Pawan, what is the value of the 1 by infinity? Pawan Yadav. No, it's not correct. 1 by infinite means? Yes, Nitesh, it's 0. 1 by infinite, that means 0. Okay. Therefore, when we apply this is 0. When we apply the upper limit, this is 0. When we apply the lower limit is 0. Therefore, e power minus 0 plus 0, but 0 have no sign. Therefore, e raised to 0. E raised to 0 is the 1, right? Minus s as it is, and this minus plus, therefore answer is k by s. Everyone clear this formula's proof? Everyone clear? Okay. Now for example, when we apply into the example, then like that. For example, mute your mic. For example, Laplace of 1. 1 is a constant, therefore 1 divided by s. And Laplace of the 100. Tell me now what is the answer? Write into the chat box. Laplace of 100. What is the answer? Yes, Vikas, f of t is the k. Here, we have to prove this, and this bracket value is the function of t. Yes, everyone write your answer. What is the answer for Laplace of the 100? Quickly write it, everyone. Trilok, Amit, Raj Roshan. Unmute yourself, Raj Roshan. Raj Roshan Patel. Yes, Raj Roshan. What is the answer for Laplace of 100? Yes, Kunal, Sridhar. Yes, very good, everyone. Yes, Raj Roshan. What is the answer? Yes, Kinjal. And when I am telling to you, unmute yourself, then quickly start your mic. Quickly. Raj Roshan.
Ma'am.
Yes. Okay, now note it down quickly. This second formula, Laplace of e raised to at. And now because your question, right into the bracket, this is written, that is always, this is the function ft. Okay, because Laplace of this, and this is the function of t, because we apply the Laplace transform onto the function of t and we are getting the answer into the function of s. Clear, Vikas? Okay. Now everyone quickly note it down, the second formula. If done this, then tell me into the chat box. Note it down this one, then I will explain to you. Now this is the second formula. Prove that Laplace of e power at, right? This is our function f of t is equal to 1 upon s minus a, where a is a greater than 0, okay? Right? E raised to at, therefore t coefficient is a with the positive sign. This is subtract into the denominator from the s. Therefore 1 upon s minus a, therefore a greater than 0 here. Right? A value is greater than the 0. That means positive. Therefore here s minus a remains as it is. Okay. Again, first write the definition formula. And apply f of t equal to e power at. Okay. Therefore, here apply f of t. This is e raised to at. F of t is a e raised to at because we have to derive the formula for e power a. Okay. Now base is the same. That's why we know that the powers are adding. Therefore, minus st plus a. Right? Now we take it common, minus t. Therefore, s minus a into the, we can write it over here, one more step, 0 to infinity e power minus t s minus a dt. Okay. Now we apply this integration. Therefore, e raised to minus t integration is same, e raised to minus t s minus a, and t coefficient is minus s minus a. वो कहाँ लिखना है नीचे, ठीक है, minus s minus a, because we apply over here integration, and the limits 0 to infinite. Again, e raised to minus infinite. Therefore, 1 by e power infinite. Therefore, 1 by infinity, and this is the 0, right, for the upper limit. And for the lower limit, e power 0 is the 1, right? E power 0 is the 1. And this minus minus plus 1. Everyone clear this formula? Yes, Karnavi? Karnavi?
Yes, ma'am. Yes.
Okay. Okay. Syed Alam? 14 number. And then Govind Kumar Pandit. Govind Kumar Pandit. Yes, Zayed. 14 number.
मैम मैं गोविंद कुमार पंडित मैम मेरा लॉग आउट हो गया मैम.
It's not log out, is in the meeting, don't worry. Okay, but he is not giving this answer, therefore I am putting into the waiting room. Okay, because when I am telling to you, then quickly respond and quickly give the answer. If you are not respondent, then you wait into the waiting room, no option. Okay, everyone clear or any doubt, then quickly raise your hand. Quickly raise your hand. Okay, now from this formula, we can derive the two formula. Laplace of e power minus, here power is the negative, right? That's why 1 upon s minus minus a, therefore s plus a. If here minus, then here plus. And in the previous slide, we derived this formula, Laplace of e power at equal to 1 upon, here power is the positive, therefore s minus a. Clear everyone? Okay, now we remove this formula because we understand the 2b also. Now, I'm giving to you for example for this one and the previous one. For example, Laplace of e power 3t, right? Therefore, 1 upon, what is the coefficient of t? 3. Therefore, this is subtract from the s. Okay, now one more example, Laplace of e raised to minus 2021t. Okay, therefore, what is the answer? Write everyone into the chat box. What is the answer? Laplace of e raised to minus 2021t. What's the logic apply over here? This t coefficient is subtract from the s, right? Here the minus sign, therefore subtracting, therefore s minus minus plus 2021. This is the answer. Now clear how to apply this two formula? Okay. Now this one. Yes. Now c raised to 80. C means c is any constant. For example, Laplace of 2 raised to 3t. Right? That's why you can understand better into the numbers. Laplace of 2 power 3t. Right? 2 constant, a constant. Now we can't apply directly because there's no particular formula for that. But this term we can write into the exponential form. And this is e raised to 3t into ln. Ln means log to the base e. Ln 2. Okay. We convert into the exponential form. 2 raised to 3t, we can write it like that, e raised to 3t ln 2. And now we can apply this formula. Therefore, t coefficient is 3 ln 2. Therefore, 1 minus s minus 3 ln 2. Right? This is the formula number second B because we derived from the formula number 2. Clear everyone? This 2a, 2b and 2. Any doubt? Yes, Manjeet. Manjeet. Priyanka. Priyanka, clear all the concepts? Okay, Kinjal. What about Priyanka? Okay, one instruction to the chat box. Okay, read it clearly, everyone. And this will follow from the next session. Now, most important property, linearity property, right? You learn when you learn the algebra, right? Associative property and all that. Here, for the Laplace transform, this is the linearity property. What is the statement of the linearity property? If Laplace of f of t is equal to f of s and Laplace of g of t is equal to capital G of s, then Laplace of a into ft plus b into g of t, where a and b, right, are the constants. Therefore, we can write constant outside of the Laplace transform. Therefore, A right outside and open the bracket, Laplace of ft plus B right outside and open the bracket, Laplace of g of t. Okay. Yes, Saurav, you want to say something? Therefore, A into f of s plus B into g of s. Okay. No problem, sir. Where A and B are constants. Again, I repeat it. Laplace transform of the linearity property. If Laplace of ft is equal to f of s, we know that when we apply the Laplace transform on the function of t, that's why we are getting f of s. When we apply onto the same way Laplace of any other function g of t, right? Therefore, we are getting capital G of s, then Laplace of a into f of t plus b into g of t. A taken common, right? A right outside, Laplace of ft plus b Laplace of g of t. Therefore, a into f of s plus b into g of s, where a and b are the constant. For example, therefore you can understand better. For example, Laplace of 2e raised to 3t plus 5e raised to minus 9t, right? That is look like that. Laplace of a f of t, this is function of t, b, this is b constant, and g of t. Okay. Now, who one giving the answer? How can write onto the left hand side? Sorry, right hand side. Raise your hand first. Quickly, it's very easy. Yes, Om Prakash. Om Prakash. Sushil Kumar. Sushil Kumar. Saurav, unmute yourself. Saurav.
Yes, ma'am.
Okay. How can we write it onto the right hand side? Laplace of 2e raised to 3t plus 5e raised to minus 9t using this one.
Yes, ma'am.
Yes. Yes, Vikas, good. To write the first, Laplace of e raised to 3t plus 5 Laplace of e raised to minus 9t. Okay, like that. Constant term, write the first before the Laplace transform. Okay, now tell me, what is the Laplace of e raised to 3t, Kunal? Kunal, 16 number. Yes, Roshan, but apply the brackets. Very good, Roshan. Yes, Kunal.
Yes, ma'am.
Yes, Laplace of 3t. You noted down the previous slides.
Yes, ma'am.
Okay, then see in your notebook and tell me what is the Laplace of e raised to 3t using the second formula.
Two into three.
1 e
Yeah.
power.
Yes, yes, very good. 1 upon s minus 3. Here this t coefficient is 3 and this is subtract from the s. Okay, now 5 And here -9. Yeah, Kinjal, very good, very good. Karnavi, yes, good. 1 upon S. Again the same thing. What is the coefficient of t? -9. Again subtract from this. And this minus sign, therefore minus minus plus. This is the answer. Right? Everyone clear? Yes, Deepak, Karnavi, Kinjal, very good. Roshan. Yes, Saurav, no problem. Because of from your side, some noise is coming with you and noise is not clear. Therefore, no problem. Clear everyone this question? This example using the linearity property as well as the formula number 2. Now, as we discussed earlier, Laplace transform are applicable for the piecewise continuous function, periodic function, and the sine function and the cos function are the piece is the continuous function as well as the periodic function. Okay. Now we find out the formula for the sine t, right? Prove that Laplace of sine kt. K is a constant, nothing else. Suppose in some reference book, suppose here sine 80, then A is the constant. You can assume constant as any variable, but not taken T or S. Okay. Sine of kt, Laplace of sine kt. The answer is 1 upon S square plus K square, where K is a constant. As well as K is a greater than 0. Okay, positive term. Okay. Now we prove this formula, we derive this result. We write the definition formula first. Laplace of ft integration 0 to infinite e raised to minus st ft dt. Right? Now Laplace of sine kt. Therefore, apply here the ft value. Now here we apply this formula of the integration. No need to apply over here the limit first. Wait a minute. E raised to ax sine bx dx. Therefore, the formula is e raised to ax a square plus b square a sine bx minus b cos bx. We know that when the exponential function and the trigo function with the multiple, then we can't apply the Fourier series Leibniz rule formula, right? Therefore, we have to apply some specific integral formula, and this is the specific integral formula, and this formula using we already done the questions into the Fourier series. That's why you already remember, but that is the recall. Please note it down. If you forgot this formula, then in your notebook, right? This integration formula apply over here. E raised to ax sine bx dx is equal to e raised to ax divided by a square plus b square a sine bx minus b cos bx plus c. But when we apply the integration limit, then no need to write the integration constant. Okay. Now here, what is a? A is a minus s. Here I am writing over here. here A is equal to minus S, B equal to K, and X equal to T. Okay, now apply these things. We compare with the left hand side, right? That's why we can identify A, B, and X. And same way we apply onto the right side. For A raised to Ax, A is minus S and X is the T. A square, therefore minus S square, therefore plus S square. And B is a K, therefore B square is a K square. A sine Bx, A is a minus S, sine as it is. B is the K here and X is a T. And minus sign, B means K, cos as it is, Bx, P is a K and X is the T. And the integration limits 0 to infinite. Everyone clear? Okay, now this limit is applicable for which variable? For the T variable. This is applicable for the T variable. T equal to 0 to infinite, right? Here T is not there. That's why we can take it common 1 upon S square plus K square. And then after we apply the limits for the remaining part, right? Now e raised to minus infinite. Therefore, we discussed earlier and everyone please remember this thing. 1 minute. E raised to minus infinite, right? You remember this thing? E is a particular value 2.7183 raised to infinite. That is infinite and that will be 0. Okay. Therefore, for the upper limit, this is 0. For the lower limit, e power minus s into 0. Therefore, e power 0 minus s sine 0 minus k cos 0. Okay. Now, everyone write your answer into the chat box quickly. What is the value of the sine 0 and cos 0? What is the angle value for the sine 0 and cos 0? Quickly. Yes, Nitesh, Kunal. Yes, one student write both the answers. Yes, Kinjal, good. Yes, Kunal, Manjit. Manjit 0 for, but for which value? 0, but for which value? Cos or sine? Okay, Manjit. And what about cos? Yes, Raj Roshan. Unmute yourself. Yes, Manjit. Okay, Zayed Alam. Okay, Raj Roshan. Ajit. Very good, Ajit Kumar. Yes, Trilok Keshriji, what's your answer? Yes, Raj Shakaria. Yes, after so many answers, some students are very active. Cos 0 is the 1 and sine 0 is the 0. Right? Therefore, this term is the 0 and this term is the 1. This is minus and this minus, therefore plus. Therefore, k upon s square plus q square. Quickly note it down, everyone. Okay, and clear all the steps. The integration formula is write it also into the above this slide. Quickly note it down, everyone. Any doubt? Then you can raise your hand. Yes, Mihir, but very late answer. Parnavi also. Okay, okay. Now we can move on to the next slide. Anyone having to remaining, then quickly write wait into the chat box. Okay, Mihir. Okay, now this is the same like the next, same like the previous formula. Okay, and here we can apply this formula e raised to ax cos bx dx. This is e raised to ax by a square plus b square a cos bx plus b sin bx. Okay, and here again a is a minus s, b is a k, and yes, you want to say something, then unmute yourself, and x equal to t. And again here the same rule applicable, e raised to minus infinite is a 1 by infinite is the 0, cos 0 is the 1, and sin 0 is the 0. Now quickly note it down this formula for the cosine. Here multiply with the s. Okay, s upon s square plus k square. Denominator is the symbol. Now quickly note it down, everyone. Meanwhile, I am taking your attendance. Okay, and any doubt, then you can tell me to me. But please note it down. You can see the PPT clearly. Today we learn the 4 formulas. First is Laplace of any constant function, right? This is k by s, then or constant by s. Then Laplace of e raised to at. This is equal to 1 upon s minus a. And from this formula, we derive one more formula, Laplace of e raised to minus at. This is 1 upon s plus a. And Laplace of c raised to at, this is 1 upon s minus a ln c. Okay. Then after, we learn the two-trigo formula, Laplace of sine kt. This is k upon s square plus k square. And Laplace of cos kt, that is s upon s square plus k square. Okay, clear all this formula. Any doubt, then quickly write into the chat box, or you can raise your hand quickly. Yes. Now, quickly we see one or two examples. Laplace of sine 3t. K value is 3. Therefore, 3 upon s square plus 3 square. because of the formula is Laplace of sine kt equal to k upon s square plus k square. And here k value is the 3. Therefore, 3 upon s square plus k square. Now, Laplace of cos 3t. This is s upon s square plus 3 square. And 3 square, we know that this is 9. You can apply over here. Laplace of cos kt. This is s upon s square plus k square. Right? Now, for the practice, you can do it this question and take it the screenshot quickly. Laplace of 1000. Laplace of e raised to minus 8t. Then Laplace of e raised to 5t. Laplace of sine 60. Then Laplace of cos 2t. Laplace of 3e raised to 3e raised to 2t plus 5e raised to minus 7t.